which is there. So which one is correct? So last one is the correct. So we'll say in this way. So first we know that how many carbon atom is there? 5. So that means pentane. Okay. So this is the alkane chain. So that is why it is known as the pentane. Pentane and 2 all. Why all? Whenever you see any alcoholic group present to a molecule, then we can say as a all, pentane 2 all or pent 2 all. Okay. So now, if we can, we give another example. Let's say instead of OH, if we have this kind of molecule, so let's say CHO is present. Now CH3, this is a CH3 molecule. Okay, so CH3, CH2, this is a CHO. So 1, 2, this is a 1, this is a 2, this is a 3, this is 4, this is 5, and this is 6. So 6 carbon atom is there. So then we can say the 16, 16, 16, and in the 3 position, in the 3 position, CHO is there. So we can say in this system 3 L. Why L? Because L, because the aldehyde group is there. So or sextanol, sextanol. So 3 sextanol. So we can also write in this way 3. So instead of 6, if we have the 1 carbon less, suppose I am erasing the 1 carbon chain. So now we have a 5. Now the 3 carbon center is there. So in the carbon number 3, CHO group is present. So we can also write in this way. So 3 pentanol, 3 pentanol. Okay. So only 2 example I am giving where the one carbon molecule, one organic compound contains OH group and another organic compound contains CHO group. So 2, 3 example I have given. Now what are the other functional group present in the chemistry, organic chemistry, and which can be used for the any organic compound nomenclature? So the order of decreasing priority for some functional groups is acid COOH, like here COOH. This is also one functional group. If you see anywhere, so one organic compound contains COOH, that means it is a acid group. Okay, so why acid group? So like in this way, OH. If somewhere OH group is present in the molecule, then it is called alcohol. So if some molecule contain aldehyde, means CHO group, then it is known as the aldehyde molecule. So if organic molecule contains OH, then this organic molecule can be known as a, or called, can be called as a acid group. And if any molecule contains with SO3H group, then you can say the sulfonic acid. So I'll give an example. Suppose MeSO3H. So this is called as a, sulfonic acid. So this is known as a methane sulfonic acid. Methane, sulfonic, methane sulfonic acid. Okay, methane sulfonic acid. And the ester group is present. If it is the ester group is present, the COOR. Suppose any molecule contain Me. I'll give an example for each of the molecule. Me, C, double OR. Known as the ethyl acetoacetate. R means any alkyl group. Let's say ethyl. Ethyl group is there. Ethyl group is there. ET. Okay. Ethyl group is there. So then it is known as the ethyl acetoacetate. Okay. Recording in progress. Okay. So then if any molecule contains COCl, then it is known as the acetyl chloride. Acetyl chloride. Suppose one molecule contains, so hello, hello, hi, hello, 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 hello. So what we have discussed. As we are here, the COCl, acetyl chloride. Now, suppose any molecule contain H3, CH3 COCl. Suppose if any molecule contain CH3, CH3 CO, CH3 COCl. Okay. So now Cl. Now here I have written the CH3 COCl. So CH3 COCl is the acetyl chloride. So suppose this molecule CH3 COCl. So that means acetyl chloride. So now other example is the other functional group is the CONH2. So if any molecule contain CONH2 group, then that means, so what we will get? MECONH2, acetamide or benzen acetamide. So MECONH2, that means it is known as the acetamide. And suppose another functional group is the CN, acetonitrile. CN is the known as the acetonitrile. So aceton, what will be the structure? Suppose methyl, we have a methyl group Me or CH3, whatever it is. So CH3CN. So now you can call as a acetonitrile. This is called as the acetonitrile. Now, as I was discussing about the two aldehyde, one is the pentanol, three pentanol, two pentanol, and three hexanol. So hexanol, if any molecule contains six carbon, so you can say the hexanol. So hexanol or whatever it is. So any molecule contain aldehyde group, CHO group, you can tell, you can call it a pentanol or means null. Suppose any molecule contains CH3, I will go one by one. CH3, CHO. So CH3CHO, that means aldehyde. So acetaldehyde, acetaldehyde, acetal what? CH3 is there and aldehyde CHO group is there. So you can call it a acetaldehyde. Okay. Now CO group. We'll go to the CO group. So what is CO group? If any molecule contain, so I'll give an example. C double bond O and Me. So that means we have a MeCO. So one carbonyl group is present here. So that means we can call as a acetone. Or if we have this kind of molecule MECOPH, that means acetophenone. Why acetophenone? pH is there. pH means benzene ring. So if pH is there, a methyl is there. So that means you can also call it a acetophenone. So we'll not go to that much depth on this particular session. So as OH already I have discussed here. So like one OH group is present in the organic molecule, then you can call it a alcohol. And NH2. Suppose one molecule contain NH2. So that means we can call it a amine, methylamine. So CH3 is there, methyl is coming from the CH3, and NH2 is there. So that means any amine. So methylamine. Okay. So that is methylamine. Now we'll go to the C double bond C and C triple bond C. So here I have written some of the example, that is alkane. Suppose any molecule contains CH3, CH2 whole to CH3. That means how many carbon is there? One, and here it is two, total three, and one carbon. Total four. So four carbon means bute, and agar if there is no such unsaturated bond like double bond, triple bond, then you can call it an alkane moiety. Alkane moiety. Okay. So now bute and N. If you see anywhere, if no such double bond, triple bond is there, so that means this is a alkane moiety. So now you can call it a butane and alkene. So if you see anywhere one double bond is present, then you can call it a CH2 double bond CH2 CH3. So but one in. That means it is called as a alkenes. Okay, alkenes. Now this is the alkynes moiety. So alkynes moiety means CH triple bond CH2 CH2 CH3. So now if you see anywhere, so this kind of C triple bond C111C, CH2, CH3. Now we'll go for the nomenclature. So suppose we'll start from here 1, and this is a 2, and this is a 3, this is a 4. So what happened? Butte. Why butte? Because 4 carbon is there. So that is why we can tell as a butte. Here also you can tell butte, but N, butane, N, it is coming from the alkane. And here alkene, butte. Here is also 1, 2, 3, and it is a 4. Okay, butte, and in one carbon there is a double bond, so that is why butte 1 in. And here 1, 2, 3, 4. So butte 1 ine. Okay, so this is a butte 1 ine. Now arene groups. Arene group. So where is the arene group? So arene group is coming from the benzene ring. C6H, C6H6. Benzene ring. Benzene ring. Now we'll count the halides. X equals to chlorine, bromine, iodine, and halogen. One bromobutane. One bromobutane, and this is a halogen. And if you see anywhere, the compound contains chlorine, bromo, and iodo. So let's say butane. In one position, one bromine atom is there. So I'll give an example. Suppose CH3 or CH2. This is a and and this is a CH, CH2, CH2, CH3. The total one bromo butane. And alcohols. What is alcohol? If you see alcohol, already I have discussed. So if you see anywhere in an organic molecule, the OH group is present, then you can call it alcohol. So one, 2, 3, and this is a 4. So that means butane 2-ol. Okay. Now we'll go to the next section. So whatever we have discussed, what we have discussed so far. So in the first slide, so we have discussed nomenclature, how we can give a nomenclature or name to a organic molecule. So suppose one organic molecule contains different kinds of functional groups like COOH, that is the acid, SO3H, sulfonic acid, COOR, R means any or any alkyl group, that means ester, COCl, that means acetyl chloride, CONH2, that means amides, CN, that means nitrile, CHO, that means aldehyde, CO, that means ketone, OH, NH2OH is alcohol, NH2 is amine, C11C is the alkene, C111C is the alkyne. Okay, so now we'll go to the CHO is the aldehyde, and the formyl butanol, like pentanol also we have discussed. So like here I have written everything. COOR, that means ester. COOR, that means ester. It goes to ester. CONH2, that means it goes to amides. NH2, that means amines. Okay. NO2, that means nitro group. SO3H, that means sulfonic acid group. Okay, I have discussed all these things, all these examples, and if you see anywhere C11O, that means it is a ketone. So one example is the CH3, CH2, CO, CH3. That is butan 2-on. 4 carbon is there, 1, 2, 3, and 3 is a 4. So in the 2 carbon, double bond O is there, one carbonyl group is there. So that is why it is known as the butan 2-on. So that is a ketone, butan 2-on, and nitrile CN. C triple bond N, it is a nitrile group. And ethers ROR, that is called as a ethers group. Okay, carboxylic acid group, COOH, carboxylic acid group. And now, whatever we have discussed, only the aliphatic system. But we did not discuss about the cyclic system. Now, we'll go to the nomenclature of substituted benzene rings. Okay, so what is benzene ring? As I have discussed in the previous class, that if you see anywhere this kind of 6-member cyclic system and aromatic group is present, that means it is a benzene ring. Now, if the simple benzene ring contains different kinds of functional group, then how to distinguish them, or how to nomenclature, how to give a nomenclature for that kind of molecule. So now we'll start from the simple toluene molecule CH3. This is a benzene ring. That means toluene. Okay, and here toluene ring is a benzene ring and OMe, that is a anisole, and benzene ring NH2, that is a aniline, and benzene ring with NO2 group, that is a nitro group, nitrobenzene, and this is a bromobenzene. Now, if we have a this kind of benzene ring with 1 and 3 dibromobenzene, so two bromine is present, so that means 1, 2, 3. So 1, 3 dibromo. This is a benzene ring, so that is why it is a 1, 3 dibromo benzene ring. Now, if we have a 1 and 2 position bromine group, then we can call it a 1, 2 dibromo benzene. And in the likewise, the same way, 1, 2, 1, 3 you have already discussed. Now it is the 1, 4 position. We start from the 1, okay, 2, this is a 3, this is a 4. So 1, 4 dibromo benzene. Okay. So if any benzene molecule contains CH3, that is a toluene molecule. If OMe is present, that is called as the anisole. If NH2 is present, that is the aniline. If NO2 is present, that is a nitrobenzene. If bromo is present, that is a bromobenzene. If iodo is present in benzene, that is the iodobenzene. Iodobenzene also you can iodobenzene we can also get, take in this way iodine. Now we'll go to the isomerism. Isomerism. What is isomerism? Existence of two or more compounds possessing the same molecular formula but different properties is known as the isomerism. So existence of two or more compounds having compounds possessing the same molecular formula but different properties is known as the isomerism. So now, so isomerism is the structural formula, structural as well as the stereoisomerism. So structural is the chain position functional group and metamerism, and the structural is the, so isomerism two way we can divide it. So one is the structural and the another one is the stereoisomerism. So what is structural isomer also we can divide it in a four way. So one is the chain, and the second one is the position structural isomerism, and third one is the functional group, and the fourth one is the metamerism. Okay, and the stereoisomerism is what? Stereoisomerism is the one is the geometrical, and the second one is the optical isomerism. So what is chain isomerism? So when two or more compounds have the similar molecular formula but different carbon skeleton. So what is chain molecule? So when two or more compounds have similar molecular formula but different carbon skeleton, that is called as a chain isomerism. And isopentane CH3, CH3, CH2, CH3, that is called as a isopentane. Now neopentane, the molecular formula is same. When two or more compounds have the similar molecular formula but different carbon skeleton. What is different carbon skeleton? So if you see this molecule and this molecule, so this molecule and this molecule, molecular formula is same. Carbon atom, number of carbon atom 1, 2, 3, 4, 5. Here is also 5. So this is the isopentane. Why? Because CH3 and CH present here. Wherever you will see any CH group, that means you can also call as a iso. And pentane 5 group is there, that is why isopentane. And neopentane means quaternary. So that means there will be one quaternary carbon center. What is carbon quaternary center? Quaternary carbon center is if one carbon atom contains four different four molecule, means there will be no such hydrogen molecule, then that is called as a quaternary carbon. Okay, so now here you can see, so here this is the isopentane, this is a neopentane, because one carbon molecule contains four CH3 group. That is why it is known as the neopentane. So isomerism is the two way we can divide it. One is the structural, the second one is the stereoisomerism. The structural isomer is the four way we can divide it. One is the chain isomerism, position isomerism, functional group isomerism, and metamerism. So what is chain isomerism? So, so the molecule can be divided in a or differentiated in a different chain way. So one is the one branch only present. Here you can see one carbon contain four four molecules. So that is why, although the molecular formula is the same, but the skeleton, carbon skeleton is the different. Now we'll go to the second one. What is the position isomerism? So what is position isomerism? What is position isomerism? So when two or more compounds differ in the position of substituent atom or functional group. Why? So when two or more compounds differ, when two or more molecule contain compounds differ in the position of substituent atom or functional group. That is CH3, CH2, CH2OH, and another one is a CH3, CHOH, CH3. Hmm. So when two or more compounds differ in the position of the substituent, we have to understand this word. When two or more compounds differ in the position of the substituent atom or functional group. So I have given two examples here: CH3, CH2, CH2OH, and CH3, CHOH, CH3. So in one way, here is the one OH group present in the terminal carbon, and the second one is the in the second carbon atom one OH group is present here. So that means what happened? That is called as a position isomerism. Why? So in one way, that is a terminal, and another example where is the internal OH group is present. So that is a position isomerism. And the third one is the key. What is the third one? Third one is the functional isomerism. So what is functional isomerism? So functional isomerism is the two or more compounds having the same molecular formula but different functional group present. Like the same way only, but here it is a in the previous one is the position. The compound can be differentiated between the position of the functional group, but here it is the same compound having the same molecular formula but different functional group. So what is the difference between position isomerism and functional isomerism? Here both are same almost, position and functional, but in position isomer the functional group will be same also, molecular formula will be same, functional group also will be same. Only the only the difference between the functional group position. So different between different between the position of the functional group. But in the functional isomerism, so two or more compounds having the same molecular formula but different functional group. So like one way, so in the first example, here it is a ketone is present, CO, C double bond O, ketone is present, and the second one, aldehyde is present, CHO group is present. Okay, CHO group is present here. Why CHO group is present? Although the and molecular formula is same, but the different functional group present. In one case, this is the acetophenone, and not acetophenone. This is the acetone. Acetone case, one carbonyl group present here, and this is the aldehyde group. One aldehyde group is present here. In this molecule, aldehyde group is present here. So, in this way, we can differentiate between the position isomer and functional isomerism. Now, I'll come to the last one, that is the functional isomerism. So what is functional isomerism? So two or more compounds having the same molecular formula. uh, the metamerism. What is metamerism? So metamerism arises due to different alkyl chains on either side of the functional group in the molecule. Okay. So let's say metamerism. Metamerism, what is the, we have to understand the definition of this metamerism. So what is metamerism? So this kind of isomerism arises due to how either different alkyl chains on either either side of the functional group in the molecule. Okay, like C4H10O, CH3O, C3H7, that is methoxypropane. Okay, and it is the ethoxyethane. So what is ethoxyethane? C2H5O, C2H5. So that is the ethoxyethane. Okay, so ethoxyethane is what? C2H5O, C2H5. That is called as a, in both cases, C2H5 and C2H5 is present here, and the other way around, CH3 and C3H7 group is present here. Methoxypropane. Fundamental concept of the organic reaction. Fundamental concept in organic reaction mechanism. So organic molecule the attacking reagent. Organic molecule is the attacking reagent, that is the intermediate to product and the byproduct. So fundamental concept in the organic reaction mechanism we'll discuss in the next class. But here I want to discuss, because we have a time, I want to discuss some of the question answer. So I'll go one by one. So as you can see, so whatever I have written here, so that is using carved arrow notation show the formation of reactive intermediate. uh, Show the reactive intermediate when the following covalent bonds undergo heterolytic cleavage. So, but so here I have taken some of the, how many question is there? One, two, three, four, five. Five question is there. So I'll discuss this thing in the lecture two. So how many sigma and pi bonds present in each of the following compound? So this one also, in the previous lecture also we have discussed sigma bond and pi bond present. How many sigma bond pi bond present in each of the following materials? So as you can see, how many sigma and pi bonds are present? The CH triple bond C, CH double bond CH, CH3. So CC sigma bond is how many sigma bond? CC sigma bond. So one is coming from here, another is coming from here, another is coming from here. So total four CC sigma bond. Okay, CC sigma bond is a four. How many sigma CH bond? So one is from here, one is coming from here, this one. Another one is coming from sigma bond is here, another one is coming from here. So total 3, and here is the CH3. Total 3 plus 3, it is a 6. Done. Now in the pi carbon carbon bond, how many pi carbon carbon bond is present here? So pi carbon carbon double bond present here is the one. Only one carbon carbon double bond is present. And how many pi carbon carbon triple bond is present here? So as you can see, so one and two. So here it is a two carbon is present here. Okay. Now we'll go to the second example, that is a CH2 double bond C, double bond C, CH, CH3. So here, as the same way, how many sigma carbon carbon bond is present here? So sigma carbon carbon bond is the one is coming from here, and another one is coming from here, and this coming from here. Total three sigma sigma bond is present. Now how many sigma CH bond? Three is coming from this side, sigma bond, and 2 is coming from this side. So 3 to 5, and one is here. Total six sigma bond is present here. How many pi carbon carbon double bond is present? So one is from here, another one is from here. So total 2 is present here. Now we'll go to the second example. Write down the structural formula of the compound. So ortho ethyl anisole. So what is ortho ethyl anisole? Ortho ethyl anisole is the, in the ortho position, ethyl group is present and one OMe group is present. Okay, so one OMe group and one ethyl group is present here. So now, so that is why it can be called as a ortho ethyl anisole. Why? In the ortho position is the ethyl group, means CH2 CH maybe is there. So in the today lecture also we have discussed, if any benzene ring contain OMe group, that is an anisole, and why it is known as the orthoethyl. I mean, this is to, in respect to OMe, in which carbon OMe is present, to that carbon next carbon is the ortho, and this is the meta, and this is the para. So as question is asking ortho position ethyl group, so that's why here C2H5 group is present here. Now write down the structural formula of the following compound, that is a para-nitro-aniline. So para-nitro-aniline is the, we know that aniline, when we call it a aniline molecule, if any benzene molecule contain nitro NH2 group, then it is called as the aniline moiety. Now in the para position, one NO2 group is present. So that means para-nitro-aniline. So that confirms us that is a para-nitro-aniline. Now the write down the, now asking the write down the structural formula of the following compound. So that is a pH, that is 2,3-dibromo 1-phenyl pentane. So first we'll draw the pentane. So how many? This is the alkane moiety. N, that is the alkane moiety, and pen in the 5 carbon. So 1, 2, 3, 4, 5. Now they are asking one phenyl. So in one carbon chain, carbon number one will put a benzene ring. That is a phenyl. So this part is done. This part is done. In one position, it is done. Now we'll go to the 2,3 dibromo. Now this is the 2. Now this is a 3. Now 2 position, there is a bromine atom present. That is 2 is done. Now 3 position. Now 3 position, we'll put another bromine. Now the whole molecule is with us. Now whatever they are asking. So 1, 2, 3 dibromo, 1 phenyl pendant. So this is the actual structure of this molecule. Okay. Now we'll go to the last one. That is the write down the structure of formula of the following compound. So 4 ethyl, 1 fluoro, 2 nitrobenzene. So first we will go to the nitrobenzene. Okay. So that is a nitrobenzene. Now, okay. So let's say forget about the 1 fluoro, 2 4 nitro, 4 ethyl, 1 fluoro, 4. So as benzene ring, first we'll go to the benzene ring. So this is our benzene ring. Now they are asking in one position fluoro will be present. So let's say we'll start from the fluoro from here. As they're asking one is the fluoro, we'll start counting from here. So then the 2 nitro. So in the second carbon atom, nitro group will install a nitro group second carbon atom. So 1 fluoro, 2 nitro is done. Now 4 position ethyl group. Now 4 position 1, 2, this is 3 and this is 4. Now 4 position if you put any ethyl, C2H5 means what? C2H5 means ethyl group. This is called as a ethyl. That is CH3, CH3, CH2. So that is a ethyl group. Okay. So in the next class, I will try to make a slide, or I'll whatever it is possible. I'll go by in this way. I'll first talk to you, sir. So then I'll go for the whether we can go by the in this way or we can go by the PPT. So let me know, and thank you for your kind information and for thank you for your kind attention.